Good evening, everyone. Thank you for joining us for tonight's vBrownBag. My name is Tom Green, and I'll be your host as we discuss serverless computing, what it is, and why it matters. Our host tonight will be Keith Townsend. We're in for a good show, and we like to keep it interactive, especially when Keith is hosting. So we'd like you to get in on the conversation. If you want to join us on Twitter, it's at vBrownBag. Our other shows, vBrownBag Latin America and vBrownBag Europe, you can see their Twitter handles there. I'll be monitoring the Twitter feed and the hashtag vBrownBag. So come at us with all your questions and your funny pictures, and we'll make sure to get them out there. So without any further ado, I'll hand it over to Keith and let Keith introduce himself and let me know when he's ready for the screen.
All right, so if you can go ahead and give me the screen, I'll go ahead and share my screen. Hopefully everyone is nice and hydrated. If you're not hydrated, I suggest you going, if you crack open the beverage of your choice. Tonight, I've chosen a Long Island iced tea. I'm in the first sip of it, so I'm pretty good. Depending on how the night goes, that may change. We'll see. Depends on the questions that you guys have for me.
So we're gonna
have to either lean on your questions or lean on my Long Island iced tea. We'll see how it goes.
It's going to be pretty interesting into the show then tonight. Stay tuned.
There you go. No, I think the show should be pretty interesting because the crowd is going to give you a bunch of questions, Tom, and this is going to go really, really well. Otherwise, I have to go into my I got some stuff I got a blog post from Warner Virgil up, some stuff on steps to code Lambda and a web page. We'll give those links out anyway, but I wanted to at least have it as backup material in case no one has questions. Because as you guys know, if you haven't done a vBrownBag with me before, I like interaction. Tom has told you this before. Please raise your hands, ask questions. The whole point of you guys giving you up your Wednesday night, which I appreciate, is for you to learn something. Even if I don't know the answer to the question, hopefully I can point you in the right direction and you get something out of this. All right, so this is a variation. Tom, can you see my screen?
Sure can. Looks great.
All right, so this is a variation of a talk I've given, paid and unpaid and just in general throughout the community and through events such as Interop and the like. Introduction, high level to serverless infrastructure. So what you should get out of this is basically a basic definition, or at least my definition of what serverless is, what it isn't, some examples of serverless use cases, some products, next steps on how to learn more about serverless. So this is a basic introduction to serverless, at least how I see the term. So quick intro, because I don't want to spend a whole lot of time on this. I've been IT for about 20 years. The past 5 or 6 years has been in more of a business type of role where I've been either a chief architect for a large government contract that Lockheed Martin had, or I was a consultant with PwC, or I'm in my current role as a enterprise architect for a large biopharmaceutical in Chicago. You can see my content, the older geekiest stuff, like how do I virtualize virtualization at virtualizegeek.com. I don't think I've posted to that in about a year, but some of the legacy stuff is still popular. And then more of my recent stuff you can find on Tech Republic, the CTOadvisor.com, and techtarget.com. So with that, let's get started right away and talk a little bit about the obvious things. There are servers in their data centers, whether it's AWS, Azure, IBM, and I'll make the argument for something like Cloud Foundry. There's servers in serverless. This isn't a magical thing that we haven't discovered a new way to compute. This isn't HP's, even HP's memory-based computing has servers and CPUs. We haven't turned computing on its head and found a way to compute without servers. So what is serverless all about? It's about developers, developers, developers. It is a different way to look at IT infrastructure, not just IT infrastructure, but a different way to look at how you serve up computing. If you think about cloud computing, all the time people will tell us that cloud computing isn't about the technology, it's about the new service model of how you deliver IT services. If cloud is about how you deliver IT services, then serverless is a subset of kind of that whole idea, that whole concept or idea. So another term that you'll see for serverless is event-driven computing. And I want to spend a couple of minutes talking about how I view this view. If the concept is to make infrastructure easier to consume for developers, then why put it in the box of saying, you know what, it's event driven? So what does event driven mean? It means that you're able to kick off a process based off of the event. So an event can be anything from you writing to a storage, a CloudWatch type of activity. So something happening with a node, let's say a node goes down and you want some correlated event to run. It's something that can't be necessarily scheduled. And if you think about it, an event could be, like a time of day in theory. So, 5 o'clock if a time hits 5 o'clock, please run a process. But this is not something that we're going to, how is that different than regular compute that runs in our data center? If you think about a server or an application, we'll start an application up, let that application run as a process, as a continually running process inside of a OS. So, if any of you have ever programmed in GW Basic, there's this basically this command that says if press any. Basically, if you press any key, something happens. So the interrupt is the PC is constantly searching the BIOS for an interrupt. So once I hit return on my keyboard, the program continues on. That's not event-driven computing. Event-driven computing kicks off a process for a predetermined amount of time for a short period based on a different event. So most of our applications in the data center are not event-driven. They might have event-driven subroutines. So after backup finishes running, delete all of the flags or change the flags, change all the archive bit flags to archived. That's a process within a chain, but we don't ever go through and like shut down the application. I mean, we don't go in and shut down a backup daemon. The backup daemon is always running, waiting to be executed. So I'm going to pause there and make sure that you guys, because that's a key concept when it comes to event-driven computing. And that's kind of how people view serverless. If you hear the term event-driven computing, people are talking about serverless. Any questions on the difference between event-driven compute and just regular compute that we see in our data centers, or even in our cloud-based applications that are not event or Lambda or serverless-based?
Yeah, actually, it's a hard concept. It almost reminds me of wrapping my head around virtualization whenever I was first learning that. Just how do you abstract away the event and the processing from an actual server itself? So
we'll get. Go ahead.
I think you did a good job of kind of introducing that concept. We've got a few comments, no real questions, except for why Graham is asking, why is it serverless? There's always something in the back end, which I think you've kind of hit on that. So we're good.
So So event-driven computing is one way to look at serverless. The other way to look at it is that at the end of the day, developers don't care about servers. Servers are a construct that we came up with as part of the client-server revolution in computing. Even as we move to virtualization and eventually cloud, if you think about it, it kind of doesn't make sense. Why, if we create a abstraction of compute, memory, storage, networking, why do we need this construct of a virtual machine? All we want are a bunch of processes that run against our data center. This is why, something like containers becomes more popular. The developers don't really worry about the VM, the operating system. They worry about the code and the code that runs against the infrastructure resources. Virtualization at some point, and this is my prediction, at some point virtualization should abstract away even the concept of a VM. There's a pool of data center resources spread across physical hosts, and those physical hosts and the hypervisor provides to the developer an API to run code against. Does that make sense to you guys as virtualization? I know vBrownBag has traditionally been virtualization focused, but as virtualization folks, can you guys see a concept where the VM goes away? And I'll wait for feedback from Tom, but the VM is kind of a legacy construct that we've created to, these set of processes talk to another machine on another set of processes. Developers really don't think like that. They think about the business problem, the code necessarily to execute the business problem, and as infrastructure professionals, we've given them the construct of a VM or a virtual machine or OS or a set of OSs to be able to run that code against. The idea of serverless is that, I have code. That code uses resources, and I'm going to run that code against my data center, not necessarily against a bunch of virtual machines, but against a set of data center resources. Serverless in a nutshell. So my definition of serverless, and this is Keith's, because most people tie it to event-driven computing. So if you go into a interview and someone asks you to define serverless, kind of like the correct popular answer is, this whole event-driven computing piece. But if you talk about, the geeky Keith architect looking into the future, it's something like Cloud Foundry, the ability to run code, to write code and push it against a PaaS. So you think about the original vision for Microsoft's Azure, Microsoft Azure, when it first came out, they didn't offer it a VM. They were like, here's a platform as a service, write code against that platform as a service, AKA sounds a lot like serverless. That's my argument. So the rest of the presentation while I'll talk about event-driven products, because most of the market manifests this way in this event-driven process technology. My broad definition is the ability to write code against the infrastructure without regard to the server construct.
So Keith, in response to your question of if we're getting it, Graham spoke up and said yes and no, and he likened it to a credit card. Mm-hmm. He said his credit card is an abstraction, but there's still money to back it up in the back end, basically.
Yeah, so Graham, that's a really great point. So at the end of the day, there's going to be individual OSs to manage. So when I deploy a serverless platform, let's say that vSphere ultimately provides the serverless platform. Well, I'm going to have servers as host, as vSphere host. I can't just go out and say, hey, give me a bunch of storage, give me a bunch of CPUs, and give me a bunch of disks. Those things have to be put into something physically. So I'll still have vSphere host in my vision or hypervisors, but those hypervisors will be invisible to the developer. So at the folks on this call, we'll still manage the hypervisor level, but what we expose to the developer is that credit card interface, is that abstraction of compute, storage, networking, and without any reference to a VM. So what we're taking away is the concept of the VM. We still have the physical host that back up those resources. Makes a little bit more sense. So for the folks on the phone, we'll still manage hypervisor hosts. We just the developer just won't see any of that. That's why I have this developers slide up. Serverless is all about changing. For infrastructure folks, it doesn't change our view of the infrastructure other than erasing the concept of a VM. For the developer, it erases the concept of the VM, and it's a new way to consume infrastructure without thinking about servers, hence serverless.
So Richard has spoke up and has asked a good question. Would you say HPE Synergy offering is going against, or is going that way?
So I can think of HPE Synergy as something that would back in a serverless infrastructure, but to say that Synergy in itself is serverless is not the case, because you're composing, this goes to HPE's composable infrastructure perspective, that you can compose, Synergy isn't going to be exposed to the developer. Synergy is exposed to us, the infrastructure professionals. So we're going to continue to think of hypervisor host, container host, etc., and we'll use Synergy to compose those hosts, to whether it's 2 CPUs, 4 CPUs, a bunch of storage, a bunch of memory, a bunch of networking, etc. So that it makes it more flexible for us to build serverless infrastructures, but not necessarily a construct that's exposed directly to developers. Make sense? Good question, though. And this is the back and forth I was hoping for. This whole concept of serverless, as infrastructure folks, the idea that there's not servers, our day-to-day, when we walk into the data center, we see servers. They might be hypervisor hosts, but they're servers. They might run containers. They might run platform as a service. They might run VMs. They might even run bare metal OSs, but they're servers. So breaking that association, disassociating the concept of servers, which is what we physically manage day to day, to a construct of what we present out to our end users to consume, our internal developers or end users to consume, as just those bare data center resources, storage, compute, memory that they can run code up against, it's a bending of the mind a little bit.
Yeah, I'm a salty VMware admin. I'm just trying to wrap my head around containers and now serverless, how that's different than a container from a VM.
So, and we'll actually get into that a little bit. So I'll save the relationship to serverless to containers in a little bit. So any questions about that developer focus and breaking through, okay, on the back end, there are servers, on the front end, we make the servers invisible to the developer. And we'll see kind of, if we have time, at the end, we'll look at kind of code examples of what the developers would write, what they push it to, and then what their experience is. Hopefully that'll help bring it home. All right, so moving on to the decision points. So from a infrastructure perspective, we have to decide if we're going to host this platform on premises in the public cloud, or have a hybrid combination where we consume some public cloud resources and we leverage some on premises resources and where we kind of break that relationship of servers and infrastructure, because there's not many applications that are really serverless end to end, not at least not very complex applications. You look at some of the Amazon material, they'll say, hey, you can build, enterprise apps completely serverless. Yeah, that's true. You talk to a lot of the serverless experts, they say, yeah, don't do that. There are some processes that lend themselves to building as a serverless process, but you still, if you do too much, everything breaks at scale. If you do too much serverless, it becomes hard to manage from a code base. So while depending on the flow of the conversation, I may talk about how we integrate cloud-based serverless solutions onto our on-prem legacy data center. That's the some of the discussion that we'll hopefully get into. I'm gonna pause for questions for you, Tom, and let me know if there's any questions. If not, I'm gonna move
on. No, I just wanted to bring up this idea of security and make sure that you're going to talk about security in a serverless world.
Yeah, I have a use case for security in a serverless world, and this is the security piece. My first serverless meetup, I think I hogged at least 15, 20 minutes of that meetup time asking security questions because I had a hard time wrapping my head around how security worked in the legacy sense in serverless. So I think one of the best ways to do this is take you through a serverless workflow. Hopefully at this time, most of us are familiar with these AWS symbols and kind of abstractions. So overall, we have our AWS VPC or data center at the high level. We are using services including CloudFront, S3, some Lambda functions, which is the actual serverless functions, S3 bucket again, some CloudFront streaming services, and on the input side of it and the output side of it, we have external devices external to AWS. So this is the deep dive. Let's have some fun. So this is a video encoding app. This is kind of the poster child and one of the simplest to describe applications to show you the power of serverless. So we have some laptop encoders that take video and post it to a S3 bucket. So at this point, hopefully if you guys haven't gone back and looked at the S3 stuff that the AWS stuff that vBrownBag did last month and the month before, you learned all about this amazing concept of S3. So S3 and S3 objects are really cool in the sense that I can consume storage without presenting it as block storage via VM. So there's headends on the AWS service that allows me to write files directly to S3. I can open up a browser, surf to a S3 bucket, and upload data directly to S3 without starting the EC2 instance. So S3, AWS's oldest service, is a online storage bucket. We're used to using this concept with, Dropbox, Office 365 with Microsoft Live, and now S3. We take files, put it into a flat directory structure with some metadata around it called S3 Magical. We can even create, if we put a start.html or an index.html file on an S3 bucket, we can actually host a static web page on S3. Everyone has that concept down, right? No questions about that portion of it?
Yeah, I think that's pretty clear. If anybody needs a refresher, just speak up and we'll help you.
All right. So no magic in that. The magic starts at this point. So just like every other system in AWS, whenever you make an API call to S3 to write a storage object, an event is created. Basically, a object has been written to your S3 bucket. It's an event. Hey, Lambda is the event-driven computing, which means that AWS can trigger a Lambda code process off of that event. So S3 alerts, and I'm oversimplifying this, but S3 alerts Lambda that a file has been written to a bucket. Based on that, the Lambda code says, oh, I'm supposed to do something. So let's look at these cascading Lambda functions. The first one is to create a copy of the video file that was written. Then it calls a process to encode that file in 480p, then transcode it in 360p, then transcode the audio, then create a thumbnail, then create QoS analytics. All of that is basically creates files that are written to another S3 bucket. Once those files are generated and written to an S3 bucket, those files can be streamed via the AWS CloudFront service from a mobile device or a video on demand mobile client based on, so this guy will say, oh, based on I'm going to contact the CloudFront streaming image. The CloudFront streaming image is going to say, oh, you're a mobile client, so you need the 363 version of the file. So I'm going to grab that from the S3 bucket. Or you're a VOD streaming mobile client, you do 480p, so I'm going to stream to you the 480p bucket. So I've created a video streaming service without servers using AWS. All right, I expect questions after that. That's a whole application that can be built without, of course, we're oversimplifying this. There's no security on this. There's no process to go back and count the number of perform any additional analytics on it, or create a database that does tracking, et cetera, et cetera. This is just a process to get the file from the video capture device into S3, transcode that into two different formats, including audio, post that transcoded video into an S3 bucket, and then allow that those static files to be consumed via AWS CloudFront streaming service. So AWS allows you to create a whole application without actually using a serverless application.
So I did get a question in of, is this sort of the process that AWS Elastic Encoder would go through if you're using their function as opposed to writing your own Lambda protocol?
That's a good question. I would imagine that they would have built their Elastic Encoder using Lambda as the back end. AWS dog foods their own stuff, so they probably built the Elastic encoder and then use that thought process to deliver Lambda as a service.
And that's Elastic Transcoder, not encoder.
Sorry, Elastic Transcoder. Not encoding and transcoding is. I thought somebody would catch that encoding is different from transcoding, but you get the gist. All right, so let's peel the onion back and take a look at some of the specifics around what happened. So the first question is, okay, I write code. When I write code in the infrastructure, I push that code to a virtual machine. I'm surprised no one asks, well, where does Lambda code live? Lambda code lives within what's ultimately a S3 bucket, we may not, what may not be exposed to us is the S3 bucket itself, but the Lambda code that exists on the S3 bucket that AWS consumes and presents to us in a code format. You guys are slipping. I kind of expected to get the question. Well, if I write, if I even if I have a container, the container has to live somewhere. Where's that container? So there you go. Next question that I'm going to ask for you guys. Well, how do I turn the knobs when it comes to performance? If a developer has a process, I can negotiate with him. Well, how many vCPUs do you need? How much memory? How much storage, etc.? How are Lambda, and this is general, and this is generic across Lambda in the other compute services as well. This is pretty much the case consistently across the board. How do I turn the performance knob for Lambda? Well, that performance knob is based on memory. You can dictate how much memory a Lambda process will take. And based on that is basically how many vCPUs and back-end resources AWS will give you to run that process. Because, of course, not every process is created equal, right? A transcoding a 5 gig file is very different than transcoding a 50 gig file. If I'm transferring the compute that I use to transcode a 50 gig file is going to be very different than the compute that I use to transcode a 50 gig file. So the way that I size it is based on the amount of memory that I dictate to the function.
Yeah, I never even
Next
thought
question,
about the.
well, not necessarily question. What was that? You had some time?
Yeah, as I said, I never really thought about the performance profile of this. I assumed serverless meant it fired off and you got unlimited resources. It's not the case.
Yeah, and this is why resources is a important concept. Functions run for no more in AWS. Functions run for no more than 5 minutes. So if we were to give the function a half a gig of memory, and we're transcoding a 50 gig file, then that function may take a half an hour or 30 minutes, whatever. We have to size it so that it runs within 5 minutes. So if it doesn't complete within 5 minutes, the function just ends. And in this process, so HQ copy, I don't remember the explanation. HQ copy may simultaneously kick off each one of these processes. It may also kick it off as a batch process, meaning HQ copy calls 480p copy, 480p copy calls 360p transcode, etc., etc. Well, if it's a batch process and the 480p doesn't finish and it just ends, then this 360p will never run. This would never run. And I'm pointing to it like you guys can see it. I'm used to giving this as a presentation in person, but the 360p would never run. This guy would never run. Thumbnail would never run, and QoS would never run if the first process didn't finish and this was a batch process. So something important to keep in mind that in AWS functions have to run in 5 minutes.
So
5 minutes.
So you can go in and define and add more memory to a Lambda function.
Correct.
Awesome.
So this is you hinted to this a little bit, Tom. Lambda scales, impressively scales, and is based on the pricing is based on the number of events. So we all know from our AWS training last month and the month before that AWS offers a free layer of services. For Lambda, that free layer of service is you can get 1 million Lambda events or functions for a month. That's a lot of events. And the way that a function is kicked off in its relationship to a container. So, as it was explained to me, there's a one-to-one mapping of functions to containers. So every time a function happens, AWS loads the code into a container. So there may be a little bit of a delay. So the first time the function is called, there might be I'm going to guess a few second delay as that code is uploaded and the container is started. But once that container is started, that container exists in AWS container infrastructure, or function exists in AWS container infrastructure. And then it's just the speed of starting a new container. So AWS can scale this as big as you need it. So, Tom, I hope this answers your question, the relationship between containers and functions. There's a one-to-one mapping of functions to containers. That's hidden from the developer. The developer doesn't know. All the developer knows is that it runs. On the AWS infrastructure side, the infrastructure operations team sees functions running in a container. Make sense to everyone?
I think my head hurts, Keith.
We might have to watch it again, Tom.
Yeah, it's
cool stuff.
It's cool. It's just a lot to take in.
All right, so I'm gonna keep giving it to you because there's more, believe it or not. So here's where we get in trouble. Lambda is like everything else. You give a lot of it, it breaks at scale. Lambda isn't going to break. The down systems break. So let's say that let's go back to our application and let's replace these S3 buckets with MySQL databases. So we're not going to, in this picture where we're serving up the storage using S3, we're not going to break S3, right? We can throw as much as we can at S3, and there's not going to be an application we can support that's going to break S3. But if we replace this playback bucket with a MySQL database, I'm going to throw this question out to the crowd to get some interaction. How do you think we can break the MySQL? What if 1,000 of these guys hit up at one time?
I'm trolling Twitter and everything, looking to see if we've got endless query. Eric Bachman says endless query.
So if we threw 1,000 of these up at one time, and this process ran, and we went to go write this to a MySQL database, and that MySQL database isn't sized correctly, this is going to fall on its knees. So this is where integrating serverless technology that has virtually endless capacity into our existing infrastructure, here's the breaking points. When we start to rely on stuff, even if it's AWS infrastructure, we can have an AWS EC2 instance that's running MySQL. But if that's size too small and we get an influx of too many functions, before we could put an artificial dampener on this whole process to avoid overloading this overhead, we can just say, oh, we can just queue up these jobs at this layer, and we can feed these instantly. Well, AWS will allow you to say, oh, if you have 1,000 things queued up, there is no queue. We'll run all 1,000 things at one time. That breaks. That's a nightmare. Actually, it probably wakes me up at night. So you can scale Lambda. You can turn the knobs on the total number of Lambda functions that you want to be able to run at one time. You can say at any given time, only allow 10 of these functions to run, 1,000 of these functions, so that you don't overload the downstream system. Okay, any questions on the code?
No, it seems clear here.
All right, guys, I hope you're having as much fun as me. I really do like these things. So
wait, we do have one from Eric Bachman again. He says, doesn't that also keep your monthly fee down?
Great question. I didn't hit on that. So obviously it does. Functions are a lot cheaper than EC2 compute. So if you're not running a static, if we're not treating this, if we don't have, let's say that all of this cascading Lambda functions was a EC2 instance that we spun up and just had idle, waiting to receive input. Well, we're paying that. Let's say that it's a big enough node that we're paying $1,100 a month for that node. If you have less than 1 million of those requests a month, you just went from paying $1,100 a month for that EC2 instance to just paying for the storage and the playback in the network playback for using the CloudFront streaming service. So you've just eliminated $1,100 out of your AWS bill. So yes, Lambda has the potential to reduce your AWS bill.
You're in for it now, Keith. We're just getting questions about code flowing in. Aaron Strong says, if I own the code and AWS owns the compute, can AWS see or monitor my code?
You know what? I've had that question and I don't know the answer to it. I'm sorry. But that is a really good question because and I'm going to answer that question with yes, because the file is a Node.js or a Python script, or you can create a C. You can compile C# and run C#. So it's just a Node.js script, and I don't, from a security perspective, I don't know if AWS has a commitment or not to not read that, but I think in theory they could.
And we got a two-parter
because if it's not encrypted, there's nothing to physically stop them from. You can't run encrypted code, so I don't think there's anything to stop them from other than a contractual agreement. I don't know if there's a contractual agreement that they won't read your code.
Awesome. Thanks, Keith.
Good question.
We have a two-parter from Graham. He says, can Lambda auto-scale the compute resources? And do you suspect that they'll keep it free forever, or do you think they'll tombstone the free Lambda event?
So I think they'll keep the million free for a while because it's a loss leader. They're trying to get more people to consume it. And you might ask yourself, well, why would AWS give so much Lambda away for free? Because it's like a drug dealer. You give a little bit at a time, and then you're stuck. Once you build, we look at kind of what Lambda works off of. Lambda works off of only other AWS events. So Lambda is event-driven compute, and all the events have to be AWS events. So this is not very portable. You can't take a Lambda-based application and easily move it to Microsoft. We'll get into it in a quick question. Microsoft Azure functions, because those you'll say, oh, once it's written to S3 storage, hold on, no, that's Microsoft storage. Or once this CloudWatch event happens, oh, no, it's not CloudWatch, it's Microsoft's equivalent to CloudWatch. You have to refactor your application. So AWS most definitely wants you to use Lambda, because if you use Lambda, you're going to consume more AWS services. The more AWS services you consume, the more locked in you'll be to their platform. So you heard it here first. AWS Lambda is the devil. My obligatory Waterboy reference. All right. Any more questions on the code?
This looks clear to me.
All right. So next area is competing solutions. So we have Google Cloud Functions, Microsoft Azure Functions, which I've mentioned before. Then for on-premises solutions, we have IBM Bluemix, which they leverage what's a open source product called OpenWhisk. When I say that it's open source in the same sense that OpenStack is open source. Most of us won't go out and roll our own OpenStack. So I looked at this when I first started looking at serverless about a little bit over a year ago. I said, oh, I'm going to try and install OpenWhisk in my lab. Yeah, no, that's not happening. If you get OpenWhisk installed in your lab, tip of the cap to you. Then the other box solution is WebTask. I think WebTask is another cloud-based solution. And these are kind of what you can. Bluemix is hybrid. You can get it in IBM's cloud, or you can. So Bluemix is the managed, provided portion of it that competes with Google Cloud Functions, Azure Functions, and Lambda. So I'm going to flow through the hybrid concerns unless you guys have specific questions about, well, what does that mean to if I'm going to run Lambda functions in AWS, and then those Lambda functions interact with data in my data center is basically the high level concerns. So from a high level, you have the same concerns we had in AWS, which is IO capacity. We're talking about drinking from potentially this huge pipe of Lambda functions. Lambda can throw more compute and data at us than more than likely our internal IO can hold. So we need to make sure we design our Lambda functions and our infrastructure accordingly so that if we have a Lambda function, let's say interacting with our on-premises hosted ERP, that our ERP backend and that transit network is able to support the targeted traffic coming from Lambda. The big question around security that Tom had. So this is something that I spent a lot of time drilling AWS on, and I'm still not 100% clear on the VPC controls. But you have VPC level controls. But remember, Lambda is a service, is not a, similar to S3. Lambda is a service, is not compute that's exposed to us. So when we think about controlling, especially in the hybrid world, saying that a process that runs on server ABC cannot interact with our credit card data. We are used to creating those types of rules. So if you've dealt with hybrid IT at all, you've generally said, okay, yeah, ephemeral smemeral. I know that you can take an EC2 host, pin it up, give it an IP address, or you can give it a repeatable IP address or a range of IP addresses, and I can block those IPs. Well, Lambda is not a server. So I can't say, hey, block this IP address or allow this IP address to access this data set. We have to focus the controls inside of the code. So this is where API level and application security becomes much more important. We can no longer default to the network as our primary method of security. So that is, I personally still struggle with this concept. It's a lot of for that reason, like one of my day jobs customers looked at hosting the application using Lambda. Lambda would have met all its needs from a application capability perspective. But once we asked the HIPAA question around, is it HIPAA compliant? AWS's response was no. So that's kind of telling how new that is. This is something, as technologists, we have a hard time understanding it. Try explaining this to your SOX auditor. That's probably not going to, or your HIPAA auditor. That's probably not going to happen.
Yeah, there's got to be some credential passing there somewhere too. You can't, like you said, you can't encrypt any of it. So, do you know how it handles that sort of?
Yeah, so we can still do public-private keys. So we can do certificate-based. We can do certificate-based uh, uh, controls. So we can do public-private keys within the application, within the Lambda. But again, it's not HIPAA compliant. So if it's not HIPAA compliant, you're not going to probably do a lot of secure transactions with at least processing secure data with Lambda. I haven't gone back to revisit what new security controls have been added over the past few months, but there are limitations of what you can do from a security perspective and what you'll be able to pass an audit or security officers' concerns. All right. So we talked a little bit about this, the on-premises options. We got OpenWhisk, again, which is that open source perspective. The packaged software product, you guys might have even seen them they've sponsored vMugs. Iron.io is kind of this on-premises. All the ability to do serverless within your own infrastructure in a packaged supported software product. Iron.io kind of leads the way. Anybody else see anybody else in the wild outside of OpenWhisk and Iron.io for on-prem server? And oh yeah, I didn't put it here. Hybrid cloud options outside of on-premises. We have OpenWhisk, Azure Stack, or Azure Stack functions on the release of Azure Stack is going to support functions out the box. AWS Snowball Edge. So AWS Snowball Edge, what was announced at reInvent 2016, out the gate, that appliance, and this is where I say AWS is sneaking into the hybrid cloud, into the data center. Snowball Edge will run functions, Lambda functions. So you can kind of picture what that means. If you can ingest an incredible amount of data, terabytes of data, on a scale out Snowball Edge unit, and then add Lambda functions to it, you can provide some pretty light but robust, some simple but robust code at the edge. So AWS gave that turbine example where you have a 4-node Snowball Edge deployment. It collects data from the edge. You have that data is collected in in S3 format. There's an alert that's generated. That alert kicks off some Lambda functions. That Lambda function runs some analytics against that data that's collected. And then depending on the function, let's say that there's a valve that's out of range, that Lambda function can either alert a knock or kick off a larger set of compute that happens outside of Snowball Edge. That's the beginning of AWS sneaking into our data centers. And then, of course, my example of non-compute based driven, just regular Cloud Foundry, where we have a PaaS sitting inside of our data center that's compatible with external cloud service providers. And I can just do a CF up, which if you think about Docker up, CF up is the developer's equivalent to Docker up. So I can say CF up and push code to my Cloud Foundry platform. So any questions on the various solutions that's out there on the market?
The only one that came to mind for me was Iron.io.
Uh-huh.
Does that run bare metal or does it run in a virtual machine?
So I'm going to hurt your head and say that it doesn't matter.
Okay. Well,
It,
I was kind
yeah,
of hoping that it was called Iron.io and required a virtual machine because I think,
that it doesn't. Yeah, that would be ironic, but
yeah.
no, it doesn't require a virtual machine.
Okay, cool.
But it can run in a virtual machine. So in theory, I can run Iron IO in AWS. In theory,
But why would you want to?
I'm sure there's reasons. All right, let's let me see where I'm at on slides. I have a closeout slide, but we're not going to close out. How much time do we have, Tom?
We're here until you're done, Keith. Just keep it coming. It's going great. And I've got a headache, but I'm learning a whole lot here.
All right, so I'm going to bring over my web browser. And this is Lambda code. So this AWS has a process. If you just Google just Lambda code, this is the first example of a project you can do with AWS Lambda, which is to create a hello world Lambda function. It walks you through this. So this is just like there's AMIs for commonly used VMs and appliances. The AWS provides Lambda blueprints. So you can pull this Lambda blueprint for Hello World. So when you go to this is a complete set of instructions on how to go to your AWS account. And again, you guys can all do this because you've signed up for free AWS accounts, and you can run this Hello World function without even writing code by just pulling this what they call it a blueprint versus a AMI straight from the Lambda repository, similar to a GitHub. Go to the next step, and then so the first job is to create the Lambda code itself. You can actually test the code to see the output. We can then invoke the code. So step 2.2 allows you to actually take the code and tie it to a Lambda or AWS event. So it can be an S3 thing. It can be a CloudWatch function. It can be whatever you want to tie it against. So this would be pretty cool to see how extensive AWS has integrated Lambda into their service offering. And then it goes into, so this was the original one is based off of Python Hello code. So if you're a Java programmer and you prefer Java, 2.3 shows you how to do the same steps, but in Java. So I think they put it right here. So it can be either a Python file or a node.js file. And you can go through, download I don't know if there's a blueprint, a Java blueprint. I think there's only a Python blueprint, and so you'd have to copy and paste this code. And then, of course, I mentioned earlier you can do this in C# as well, but you'd have to it doesn't have a C# compiler, so you have to upload the compiled code binaries. So I thought I'd show that quick, just practical. Let's go into AWS, see where the stuff is at. Now, if your head isn't hurting enough, if you're not Tom, you say, Keith, I want more. Well, you go to Werner Vogel's website, All Things Distributed, and he has serverless reference architectures for AWS. I think he gives 3 or 4 reference architectures, one for a mobile backend serverless reference architecture. So they talk about this a lot. If you're a mobile developer, chances are you don't know a whole lot about infrastructure. So if you're building a Flappy Bird type of application, there's a big need for back-end infrastructure. But you're a front-end developer, this reference architecture can be used to create a serverless back-end for Flappy Birds or any other mobile application. There's an example for a real-time file processing serverless reference architecture. This is closer to that example that we just gave you for the transcoders. There's a web application serverless reference application. So remember, again, a combination of, we can use S3 as our web server, and Lambda and DynamoDB and all the I can create a serverless application without ever starting up an EC2 instance. Even when we run what is that, hosted? I don't know if any of you host your WordPress in AWS, but I think that's an actual EC2 instance. If I remember correctly, it's not. AWS doesn't offer a WordPress service. They offer hosted WordPress that gives you EC2 instances that potentially auto scale. So it's an entire EC2 environment in which you can host your WordPress. This is taking a web application and hosting it natively in AWS without servers. IoT use case, you can't get away without a buzzword of IoT. Will live stream processing. This is, I think, that exactly that use case that we gave at the beginning. So we'll close out. But before we close out, any questions?
We have quite a few here. So
good.
I've been queuing them up, apparently.
Okay.
So Kenneth wants to point out that Fission is an open source project for serverless from Platform 9.
You know what? I got to see what Fission, I remember them announcing that. I have to see what it's based on.
Yeah, it may have been Kubernetes. I'm not going to say that for sure, but I remember seeing that in Tech Field Day.
So if you remember, we said there's a one-to-one relationship. You can easily see how containers, how you can build this using a Kubernetes for data center management, but using some type of front end to get then you just need the code management to say take the code, run it in a container.
He confirmed as Kubernetes is the back end.
Okay.
He also says acloud.guru runs entirely on Lambda, including all of the learning modules. And Eric is trying to get me to set off my Echo behind me. He says, why don't they just throw Alexa at Lambda? Then you can tell Siri to remind Alexa to push Lambda, a service telling a service to manage a service.
There is Alexa-based Lambda services. Alexa is one of the, I think, I'm almost certain Alexa is one of the keys that you can actually create a completely Alexa app based completely on Lambda.
And there's all kinds of beeping going on behind me every time you say that name. All right, is there any other questions real quick before we let Keith wrap her up? All right, Keith, I'll say that there's no questions for now, so take her home.
All right, so bottom line, reminder, there's servers in serverless. For the folks on this call, on this webinar, more specifically, we're going to have hypervisors. We're going to have bare metal servers. We're going to deal, unless we're dealing with AWS directly, us, the operators, we're going to see the servers. The developers, the shift is that the developers no longer see servers. They only see code. The knobs that they get to turn is generally about memory. How much memory can I throw at this function? Processes that are events-driven or batch in nature. So again, this is kind of when you need to go on this interview and you were like, oh, I remember Keith gave a vBrownBag a couple of months ago, and he said Cloud Foundry was serverless. The whole reason why I'm doing this vBrownBag is because me and Cody got into an argument about whether or not Cloud Foundry was serverless. And he said, oh, you just volunteered yourself for a vBrownBag. So there you go. So don't follow the Keith advice and go into a interview and argue why Cloud Foundry is serverless. Cloud and on-premises options. So we went through the various options and we got a couple of new ones. Fission was one. I really appreciate that. I'm going to take a look at that again. And we actually went through and looked at some code pointed you guys to how if you're so geeky inclined and you want to do a basic hello world application, AWS lays that out for you. So just as an operator, you understand the vision that the developers have. The view that the developers have. So with that, we're going to close out. Any questions in general? Any closing questions?
Looks like there's some salt about your Cloud Foundry comment with Kenneth saying it's definitely not serverless. So you better watch out. You might have to do another vBrownBag or another.
No, I'm not going to volunteer myself for it. Ken has always argued with me that's just, he's for the past year and a half, he's argued with me that it's not Cloud Foundry. But I have the mic and he can't talk on it, so it is serverless.
And we have definitively decided Cloud Foundry is serverless. So there's no other vocal objections. So I think that'll wrap us up for tonight. If you're okay with that, Keith.
I am okay, and we can cut off and we can go into our questions if there's our unrecorded questions, because there usually is more recorded stuff.
Yeah, so that's a little teaser for anyone who's listening to the recording. If you show up live, you get some Stump the Chump conversation. So please join us next time live and ask us all kinds of questions. And Keith, I think it's been fantastic. Eric Bachman says, great job. Good info. So thank you very much, man.
You're welcome. Thanks for everyone for joining.